Swayam Prabha. Digital India. Educated India.
You are interested in the extremum values of normal stress okay. The normal stress is denoted by sigma of n, is nothing but T's of n dotted with n, which will be nothing but sigma transpose n dotted with n. Okay. Now, with respect to a particular orientation of the axis, you have sigma, the components of the stress sensor. Now, with respect to the same coordinate system, you want to find the components of the normal, so that this quantity is maximum. Okay. In other words, you add sigma x star as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus sigma xy sin 2 theta, right. If I want to maximize this value, what should I do? I have to take a derivative of sigma x star with respect to theta, set it to 0, then what do I get? I get minus sigma xx minus sigma yy by 2 sin 2 theta plus into 2 plus 2 times sigma xy cos 2 theta equal to 0. This expression is essentially 2 times sigma x star y star. So, maximization of the extremum normal stress requires that sigma x star y star be 0 on that plane. So, the shear stress on the plane where the maximum normal stresses occur will be 0, okay. And this gives us also the expression for tan 2 theta as sigma xy 2 times divided by sigma xx minus sigma yy, okay. This is the principal plane theta p, but theta p represents the orientation of the plane where extremum normal stress occurs. Okay. Here you have to note, if you are using a calculator to compute theta p, it will give you tan 2 theta p in the range of minus pi by 2 to plus pi by 2, okay. That is not what we want. We want tan theta to vary over the range 0 to 360 degrees, not plus 90 to minus 90, okay. That is, it matters whether the numerator has positive sign, negative sign, or denominator has positive sign or negative sign, okay. So, you have to see that if numerator is positive, if sigma xy is greater than 0 and sigma xx is greater than sigma yy, then 2 theta p would be between 0 to pi by 2. If sigma xy is less than 0 and sigma xx is greater than sigma yy, 2 theta p in this case would lie between pi by 2, in this case it lie between pi to 3 pi by 2 to 2 pi, okay. If on the other hand sigma xy is less than 0 and sigma xx is less than sigma yy, 2 theta p will lie in the range of pi to 3 pi by 2. Okay. That is, depending upon what is positive, your domain in which you have to find theta p will change. Okay. Now finally, if sigma xy is greater than 0, but sigma xx is less than sigma yy, this would imply 2 theta p is in the range pi by 2 to pi. Okay. So, depending upon what range your theta p is, it will be on different orientation of the planes. Okay. Now 2 points we saw, the plane on which the extremum normal stress occurs, we understood that the shear stress will be 0 and that angle is given by this expression tan 2 theta p is 2 sigma xy by sigma xx minus sigma yy. Okay. And we understood that this theta p 2 theta p has to be found over appropriate domain, which is 0 to 360 degrees. Okay. Now let us find where the maximum shear stress occurs. Extremum shear stress. Okay. We got in sigma x star y star as minus sigma xx minus sigma yy by 2 sin 2 theta plus sigma xy cos 2 theta, right. To get the extremum shear stress, I have to differentiate sigma x star y star with respect to theta and equate it to 0, which will give me minus sigma xx minus sigma yy by 2 times 2 cos 2 theta minus 2 times sigma xy sin 2 theta to be equated to 0. This will tell me tan of 2 theta s is sigma xx minus sigma yy by 2 times sigma xy. Okay. Now here theta s is the orientation of the plane on which the maximum shear stress occurs. Okay. Here again 2 theta s as a domain 2 theta s varies between 0 and 2 pi or 360 degrees. Okay. It is not over 0 and 90 degrees or minus 90 and plus 90 degrees. Okay. So, you have to be careful on how do you select the domain of this solution. Okay. So, what will be the, we have found the orientation of theta s at which the maximum shear stress occurs. So, what is the value? Sigma x star y star maximum would be minus sigma xx minus sigma yy by 2 into sin theta would be plus sigma xx minus sigma yy by 2 and in the denominator you will have sigma xx minus sigma yy by 2 the whole square plus sigma xy the whole square, right. And then for cos theta it is going to be plus sigma xy into sigma xy by, if I call this r, if I call this quantity r under the square root term, that is going to be sigma yy by r. Okay. So, what is this? This is nothing but r square divided by r, which is nothing but r, that is square root of sigma xx minus sigma yy by 2 the whole square plus sigma xy the whole square. Okay. This is sigma x star y star maximum. Okay. So, that is the maximum shear stress. Now, let us go back and find what is the maximum normal stress. We found that tan 2 theta p is this. So, the maximum normal stress would be, the magnitude of the maximum normal stress would be the following. Magnitude of normal stress when maximum shear stress occurs. Okay. We saw that the maximum shear stress occurs when tan 2 theta s is given by this expression. Now, I want to find what will be the normal stress when this maximum shear stress occurs. Okay. So, I know tan 2 theta s is given by minus sigma xx minus sigma yy by 2 sigma xy, and the normal stress sigma x star is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos of 2 theta plus sigma xy sin of 2 theta. Okay. I substitute for theta 2 theta this expression, then I will get sigma x star at max sigma x star y star to be sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 into sigma xy divided by r, where r is same as what I used before, plus sigma xy into sigma xx and sigma yy by 2 into minus 1 divided by r. You can see that these two terms cancel, and hence it is sigma xx plus sigma yy by 2. Okay. What we have seen is, when the extremum normal stress occurs, the shear stress goes to 0, but when the extremum shear stress occurs, the normal stress is not going to 0, it will be the center of the circle. Okay. Now, let us go back to the circle and identify these points. Let us go back to the circle and identify these points. We saw that these 2 points are the extremum normal stress points. The extremum shear stress point would be this vertical line. This vertical line centered about 6, that will be your tau max. This will be your tau max or sigma xy max. Okay. So, that will be your maximum shear stress, and you can see that it occurs at the center of the circle, and its magnitude is equal to the radius of the circle r. Okay. So, now we have to mark what the angle 2 theta p and 2 theta s are in this circle. Okay. Now, we saw that tan 2 theta p was sigma 2 times sigma xy divided by sigma xx minus sigma yy, and tan 2 theta s was minus sigma xx minus sigma yy by 2 sigma xy, right. Okay. Now, what is theta p? Theta p is the clockwise rotation. This is the plane on which we add the stresses, and the pink one, this is the plane on which we add our stress state, and this line represents the maximum extremum normal stress plane. Okay. So, a clockwise rotation from this plane to this plane by an angle 2 theta p will give you the orientation of the maximum normal stresses. Okay. 2 theta s on the other hand would be, this 2 theta s represents the plane on which the maximum shear stress occurs, that will be a clockwise rotation from here to here, this will be 2 theta s. Okay. So, basically now what can you infer from this? The plane from which the maximum normal stress occurs and the plane on which maximum shear stress occurs are separated by an angle of 90 degrees. So, this clockwise angle is 90 degrees. Okay. What it means is the plane on which the maximum shear stress occurs, the plane on which the maximum normal stress occurs are related through a 45 degree plane in the actual thing, because the rotation of the plane is theta p and theta s. Here the rotation in the Mohr circle is 2 theta p and 2 theta s. Okay. So, basically now if the angle made by the two planes in the Mohr circle is phi, the angle actual angle would be phi by 2, the rotation of the planes. Okay. That is a theta degree rotation, a phi degree rotation in the coordinate system. Say this is Ex p, the plane on which the maximum normal stress occurs, this is Ey p, and the plane on which the maximum shear stress occurs, this Exs, Eys. Okay. This angle is 45 degrees, so that it will be 90 degrees in the Mohr circle. Okay. That angle is 45 degrees. Okay. Now, from this figure it is clear that the extremum normal stresses expression would be sigma xx plus sigma yy by 2 plus or minus r would be your sigma x star max and sigma x star minimum values, right. In fact, plus r would be sigma x star maximum and minus r would be sigma x star minimum value. Okay. So, we have found the principal stresses, these are called as principal stresses or another name given for this is eigen stress. Okay. Both mean the same, eigen stress or principal stress, both of these means the same, it means the extremum normal stresses that can occur for a given state of stress.